Is your BGP session secure? In this video series, we are going to talk about how you can make your BGP session secure, and we are going to demonstrate them using our lab examples. Before we jump into the configuration and lab scenario, let's look into the real world. What's happening with BGP? So BGP security is utmost important. We see many news articles across the globe. You can just Google and you will find some news articles like Ukraine suffer a BGP hijack. You will see some tweets like over here. Mr. Bart is saying that Russia is intentionally rerouting and sniffing massive amount of internet traffic from Ukraine. He called it as a BGP hijacking. Mr. Jang is talking about potential BGP hijack. So there are many articles and many newspapers talking about BGP security issues. And we see one very interesting article over here, bleeping computer. Now the bleeping computer talks about the Cloudflare has the global DNS IP address 1111. Now this IP address, as per this bleeping computer coverage of this news, was being hijacked. So a route hijack, commonly referred in the BGP domain, where the route has been being advertised falsely by some another autonomous system. So now this was being reported by the Cloudflare network that their route for this global DNS was route hijacked. Now the users which were supposed to go to Cloudflare, not all of them, but some of them were preferring to go to a fake IP address which was hosted by this autonomous system. Tech Spot is talking about that White House declares BGP security issue a national priority. So now we see that this is very critical and very important issue. We have to dive into it. So let's now move to our case one or scenario one. So in this scenario, we have two routers, R1 and R2. R1 is in AS100, R2 is in AS200. And same, if you have been following us in the previous labs, I usually keep the loopback IP address with the third octet as the router number. So this is 111.1 and this is 112.1. This time we are going to look into very fundamental issue, which is how to make our BGP sessions secure and safe. So you might be thinking like why we really need to make BGP sessions secure. Maybe you might not think that it's so much critical, but if your BGP sessions are in public network or even in your own private network and you have BGP sessions running, there can be several things which attackers can manipulate in your BGP session. So having a MD5, at least an MD5, is very important. But there are some challenges with the basic password authentication or basic MD5 authentication. So we are going to talk about it. So let's start with the very basic. So we have a BGP session already established between these two routers. I want to show you that that how can this be a vulnerable, right? So we have this BGP session on R1. This is the console to the R1. I will show you what we have configured over here. So show run router uh, BGP, show run router BGP. So you see that I have a very basic configurations over here right now. I want to gradually build up. So in this series, first I'm going to do some basic configurations only, and then later on I will start using the route maps and all other policies and security stuffs. So we will gradually go towards making it more secure. So now right now what I'm going to show you is like this is a very basic configuration, no password over here. Something same is configured on the show run router BGP. So the neighbor router is also very same. If I see the BGP session, it is let's see, show BGP summary. Yeah, the BGP session is already up. So I'm going to do a Wireshark, not on the directly connected link from the R1 to R2, but I have put a layer 2 switch, and this is a third link. And in the third link I'm going to see that what we can see using this Wireshark. So while the Wireshark is loading up, so what we see over here is that there are TCP packets over here, BGP open messages, everything being sent in a clear without any MD5. So what can happen? The source and destination is known to anyone who is doing sniffing on your packet, right? On your link, anyone who does the sniff can find the source and destination. Once they know the source and destination, they can replicate the session. They can hijack your session with the router R1, like they can put some BGP speaking device over here, establish a BGP session with your R1 router, or they can replay, like they can inject some default route to your network and screw up your network. They can also, like, let's say there is a secure server behind R2, they can replicate a session same like R2 and replicate some secure server in their cloud, right? So many things can happen. For us, it's important to know that we need to make our BGP session secure. Now we are going to work on a second scenario. In this scenario, what we are going to do is that we are going to use some BGP password in between R1 and R2. This is going to be a very simple BGP password. We are not going to use anything like TCP authentication option or MD5 keychain or anything, but a very simple traditional MD5, which is also a very good thing to do. Like, you can even use a simple BGP password. So I will show you what I'm talking about. Configure, let's roll in our passwords over here. So here we go, router BGP 100 and neighbor IP address and then password. But you see, I am using a very simple password just because we are doing a video recording right now, and just for lab purpose I like to use I like to keep the things simple. But in production, never use a very simple password. You have to use a combination of alphanumeric characters, some special characters, and shouldn't be any word from dictionary. Make it difficult. Same like you use a very complicated password for your Windows or for your online website or anything. Yep. So now I have put the same password on both sides. Since we are using IOXR, so we have to use a commit on both sides. Okay, now I will also do, just for the sake of time, I want to do a clear session so that the BGP session will flap quickly. So clear BGP star. So I will just do a hard flapping right now. While the BGP is coming up, I also like to run my okay, the Wireshark. So it's now starting over here. The Wireshark not took much time. I can see that new messages are now coming up. The update messages are also here, and we can see that there are many things with TCP MD5 signature in them. So the update message is also with TCP MD5 signature. So right now we can see that we are using MD5 authentication. Now if you have been following my videos, like in past, I have also made more videos related to the BGP authentication troubleshooting, right? I have make a similar scenario where some I will put a link above for the troubleshooting session of MD5 authentication, which if you guys are interested, you can have a look. Now coming back to this video, so now we have established a BGP session with the MD5. We know it's secure, but is it all done? No. Maybe some hacker who is doing a sniffing over here, he can see your Wireshark. He can do something more. What he can do is, like, he can take this MD5, he can do some sort of brute 5. He can decrypt it, right? So there are like really good NVIDIA and devices hardware available which can help you to decode stuffs, and also they can do a brute force, because once we configure MD5 between two routers, these BGP session is keep on running for years, right? So anyone can make a misuse of it. What they can do is that they can do something like a brute force attack. They can do something like a replay attack. Replay attack is like capture something using the like using the same way we are capturing, like via a layer D device or a tab. You capture it and then you replay the same sessions to hijack the BGP. And also you can do something like man in the middle attack, right? So there can be many vulnerable things which can go over here. So it's always advisable, like, you keep on changing your Windows authentication password or your um, social media password and all the passwords online we use. So same way, we also recommend that for BGP also keep on updating your password. But is it very simple? No, it's not. Because let's say if I update the password over here, password underscore 2, okay, and also I'm going to do a password update over here as well, underscore 2. Okay, yeah, the password has been updated. By the way, just updating the password with a 2 at the end is not a good idea. Whenever we update a password, we use a new password in the real life, we don't just append a new numeric at the end, we have to make a completely new complex alphanumeric password. For the lab purpose, I'm just making it underscore 2 so that the users will be able to understand that I'm using a new password. I'm going to do a commit. Okay, and I'm going to do a commit. So now this is very cumbersome because every time you have to manually update the password, it is going to flap your BGP session. You cannot track it, you cannot schedule it. You might have to go into a LSU because usually these BGP sessions are carrying live traffic, and you cannot update them when your user are using your services. You have to go in a downtime, you have to notify your customers. So in order to be safe, there is a better way to do the update of password, and that's using the keychain. So in this scenario number 3, I'm going to use the keychain. So let's look into the scenario number 3. So now in the case 3 or the scenario 3, we are going to use a keychain. Now keychain, as we have in different algorithms as well, we are not going to just define one password, but we are going to make a schedule. Yeah, we can say it like a schedule. So I just make a schedule we get for the first 6 months of 2025. So what we can see is that what I have done is like one key I'm going to use for the month of January, another key for Feb, March, April, May, June, and then this schedule is going to continue. Maybe by the end of May, I'm going to make more keys for the coming months. So this is how the key rotation schedule is prepared. But what we can do is like we can make it more aggressive. Like you can make it on day basis, or you can make it on hour basis, or you can make it on base of quarter. And also you can use some sort of automation or a scripting tool to make it automated and updated regularly. So that will be a very interesting experiment if we make it automated. So maybe next time, sometime we can do some automation like that as well. But for the time being, we are just going to leverage whatever is in iOS XR. I'm just simply going to use a simple keychain with these 6 keys. These password, as I have said many times, are very simple password only for the lab purpose. Please don't use simple things in the real scenario or in the real environment. Okay, now let's go back to our lab. Just for your okay, let's start configuring. So configure. Now I'm going to start the configuration of keychain. So I will call it like keychain keys. Okay, just a simple name this time, and the first key I'm going to put the key string over here, and then I'm going to see what algorithm options we have. So we have like many cryptographic algorithm option. Let's look into it. I will pick HMAC because our purpose right now is just to experiment keychain. You can use any other if you like, but I'm just going to simply use HMAC MD5. Then I'm going to use the send lifetime. So the send lifetime is going to be something like this. So it is going to start on the first day, first hour of January, or the 0 hour of January 1st, and until the last minute of January 31st. Okay, but you might be thinking like, if this is the send life, then we also have to send something like accept lifetime, because the neighboring router will also send the same key to us. So we have to tell that for what time duration we can accept it. Okay, so now we can put the same time over here for accept as well. Okay, so let's say if we put the same time over here. Now, I'm thinking if we put the same time, let's imagine if the NTP timing between the two routers are not very synced with each other, if they are like few seconds apart from each other. Like if my router on the router R1 side updated its password, but my friendly router R2 hasn't updated its password, or there is some transmission delay, then we can risk ourselves for a BGP flapping. And in the production environment, like these BGP sessions, like they might be carrying some critical traffic for our customers. Okay, so what we need to do, we need to set something as like accept time. Let's make it like 5 minutes earlier. Like it will accept this key 5 minutes earlier, and will also accept it even 5 minutes later. So we are making a grace period of 5 minutes in the beginning and 5 minutes at the end as well. Okay, so just trying to make it like 10 minutes extra. So here we go. So this is like starting from 31st December until the 1st Feb. Okay, now just for the sake of time, I have actually prepared off all of this configuration in a notepad. And by the way, I think if you guys are following my videos, what I do is like all the configuration of my lab, I'm going to put in a share folder. I will put the link for the share folder in the description. So if in case you want to retest it, you can do the retesting at your free time. So you don't have to type all these configurations. You can focus on your experiment. So I have these 6 keys already typed over here. I will copy it and I'm going to paste it over here. So you see every month these keychain will be updating, and it will not, like, no matter how fast we are, if we are manually changing it, we can end up in screwing our BGP session. We can flap it, right? So this is going to be a bit better. Now let's go into the router BGP configuration, remove the passwords and configure the keychains. Okay, so here I am. I will go over here, keychain keys. This one also keychain keys. Okay, show. Perfect. So I am going to commit it now. In fact, I have to commit twice because this commit also, and there is some configuration I have in the previous one as well. Like the commit, the keychain I haven't committed yet. So let me go back and commit it. So I'm going to commit this router right now. Okay, and then I have to go to exit and then do show keychain. Let me see if the keychains are there. Okay, good. And over here I'm having an error because I pasted router BGP 100, which is incorrect. So I have to clear it and put the router BGP 200. As I was saying earlier, that we can end up in, like, no matter how quick we are, we can end up in a scenario when we have two different passwords, right? If we are working manually. So I did found some invalid EA digest in between, but then I went and commit and my BGP session is now up, so it's fine. Now we are not getting those authentication MD5 errors. So now I will show you something interesting, which is like show key chain. Now we do the show key chain. We see that key 3 is being used right now. Key 3 is valid, so it's for the month of March because today is 9th of March, so it's valid right now. And over here also in this router show key chain, so we see that the for the month of March we have the this key already valid. Now let's imagine there is a time period when by the end of March, when this key send life is going to expire and we are going to use the key 4. So when we use the key 4 on the 1st of April, that the 0th hour, what is going to happen, right? So there is obviously going to be a time of with the overlapping of the keys between these two. Okay, so let's do it manually. What we are going to do is like we are going to play with our clock of the router. So I'm going to set it as the 1st April over here and 1st April over here. So the 1st April is set on both of these routers. Let's go and see the show key change. You see, this is interesting now because you see that both the keys are valid right now. Key 3 and key 4 is valid. So whenever there is a time when the key has to be updated, it could be end of quarter or end of month, at that time the previous and the new key both will be valid because we are configuring an overlapping keys, right? So do show do show sorry show key change. Show keychain, same thing is on this router as well. So this is all what I wanted to talk about keychains. Next I want to talk about some common error that often people do while configuring the key change. So now we are going to talk about common issues and common mistakes while configuring the keychain. So now the common mistakes that I have seen is like one of them is very common, which is like it's very hard to find out, but it's something like, let's say if the key number 3 is not matching the key number 3 over here, now it will be very difficult to find out because these are already encrypted, right? So you cannot troubleshoot or find out if they are matching or not. So the best thing is that we match or at least copy paste it from the same location of the file on these routers. So when we are configuring, we make sure that we don't put in any extra space or extra character while configuring the keys on the two routers. The another thing is more interested related to the accept lifetimes or the send lifetime. So you see the timelines need to match. That's why if while when I was configuring these routers, I use the same configuration, copy pasted on both of them, trying to make sure that all the timelines are matching. So you see the timelines are matching. So we have to make sure that our send lifetime and accept lifetimes matches on both the routers. The other thing is the time zones. Like it's better to have the NTP and have the same time on both the routers. Otherwise, like if there is a time mismatch, then again the keychain won't be working perfectly fine. One more thing which is like which sounds very strange, but it can happen, and that's like some people can forget to apply it on the BGP because we are configuring a very long keychain. So it can happen that at the end we might not put the keychain keys command into the neighbor, right? Or we might put it in on some different neighbor. So these were all the common issues which I can think can happen or I have seen happening with the keychain. Now stay tuned with this because I'm going to upload more videos. This time it was related to key change. Next I'm going to do other BGP security features. So I want to make a series of certain BGP features, BGP security features, which I would like to cover up in this series. Thank you. Thanks for watching.